Okay, the last two assignments, 7 and 8. One's a confidence interval, one is a hypothesis test. Again, neither of the tests or setting it up on the computer here are very hard to do. It's all going to be in the interpretation, but I'll show you how to do it. Go to Stat, Proportion Statistics, one sample with summary because I gave you that data. And we're going to do a confidence interval for assignment 7. The number of successes is going to be, in this case, X. There are 79 successes, or we saw something happen 79 times out of 525 times. And that's a proportion, but this would be our particular sample. We did this once. We saw 79 out of 525. If somebody else did it, they might get different numbers. If we did it tomorrow, we would get different numbers. But for today, in this one sample, this is what we got. So our confidence interval is we're going to be 95% confident that the true proportion, okay, is going to lie somewhere between a lower limit and an upper limit. Okay, our proportion is going to be exact. We can figure this out. Okay, our proportion is going to be, I think, somewhere around 15%. But the true proportion, because there's some wiggle room, is going to be lower than that to higher than that. And that's going to be our confidence interval. Let's find out what it is. Compute. Okay. Yeah, 15% is our sample proportion. 79 out of 525 is probably 15.047%. Okay? But at the 95% confidence interval level, I guess, or at 95% confidence, we think the true proportion might be between 11.98% or 11.99% and 18.11%. Gives us a little wiggle room. That's all a confidence interval is. Let's try a hypothesis test. With summary. Okay, now we're going to click hypothesis test. I tell you in the problem that the p should be 0.25. Okay, we want it to be less than that. How many successes did we see? Well, in this example, we saw something happen 110 times out of 525. Okay, so this is a different result. Okay, and as far as a hypothesis test goes, we will compute and we'll say, and we get a z-score of negative 2.14 and a p-value or a proportion of 0.0161. So basically, about 1.6% of the time, we would see values like this according to random chance alone. So we're not, this 110 out of 525, if it's only going to happen 1% of the time, or say less than 2% of the time, that's pretty unusual. So our sample, 110 out of 525, is unusual. So probably we're going to say that this number, our hypothesis, isn't right because the number we actually saw was so unusual. All this will be made clearer, hopefully, as the year goes on, but that is sample, or rather summer assignment 7 and 8. That's it. Hope you had a good summer. See you in a few.